Hello, everybody. Thank you for taking the time to join us for this informational webinar. My name is Mui, and I'm a product manager with Gusmer Enterprises, the U.S. distributor of IFF Nisco Enzymes. Let me go ahead and introduce our speaker today, Andrew Fradiani. Andrew is the Senior Product Application Specialist for IFF. Prior to his position, his past roles included brewmaster at both Pabst Brewing and at Yuengling & Son. Andrew was also the Senior Technical Sales Rep for BASF, as well as the Technical Sales Rep for Gusmer. Andrew is also a member of the MBAA, the ASBC, and the Institute of Brewing and Distilling. Please give Andrew a warm welcome. Andrew?
Great, thank you. Thank you very much. Thank you for joining today, everybody. I'm sure by now you've heard something about the 2021 barley crop, both here in the United States and Canada, and eventually, quite soon, that barley will be making its way to your brewery as malt as early as next month, December, and certainly into January, February, March. And so today I wanted to go through what has happened. We've had a lot of heat and drought stress. There's also been rain at harvest, so pre-harvest sprouting, what that does to the plant, what the effects are, and what that means for you. And so at the end, we'll look at some enzyme applications that you can use to help reduce the problems that are caused by this barley. So the overview for 2021 in North America. And I think it seems that it's going from bad to worse. The more we learn about this, that doesn't mean it's hopeless, though. And I think one way to prepare is just to get a better idea about what to expect and what you can do. And there are a lot of variables that will actually affect how bad the drought was or how bad the heat was on there. So, how bad is it? Well, it all depends. We'll go through that now. So there's many factors here. First of all, we're looking at the type of stress that happens. And normally you're dealing with heat stress, so very high temperatures during growing season. You're dealing also with drought separately. This year, we happen to get both of those together. We got heat plus drought during the growing season, and the effect is cumulative there. So when you have heat plus drought, the effect and the stress is much, much greater on the growing barley. But there are other things to consider. So the location, the growing location for malting barley in North America stretches from Minnesota, North Dakota, Montana, up into the prairie provinces of Canada. You have growing conditions. Many areas of the Western US are growing barley on irrigated land. In the upper Midwest and into Canada, most of that is dry land. And so drought is going to be a significant factor there if it's not irrigated. The barley type. We're using mostly 2-row barley now for malting in North America, but there still is 6-row barley grown, and its response to these stresses is different. You have also typically spring barley and winter barley varieties. We're going to see that the drought occurrence. So when did this happen? During the growth cycle. So when it happens has an effect on how significant the effects are. The weather and particularly rain just prior to or during harvest is a completely different effect and stress, and you'll have pre-harvest sprouting. So the kernels out in the field or still on the stalk will begin germinating and growing, and that's a different and difficult problem, and you don't want that. And then finally, we'll go through some options here. What can a brewer do to alleviate some of those problems that we know are coming? So we know problems are coming. We don't know the intensity or how widespread they will be. So stresses on the growing barley. It can be drought, and the impact from the drought depends upon how long that drought is and how severe it is. up in the prairie provinces in Canada, they've had up to 50% less rainfall this year in 2021 than they do on average. So that's a significant drop in moisture and precipitation, especially if you're on dry land. That really hurts the barley. Heat. Heat is generally going to result in reduced grain weight. So a thinner kernel usually means you have less starch and less available extract. And that also means, conversely, that you're going to have higher levels of protein. And that's really what we're talking about this year, is the high protein levels. The amount of protein per kernel is usually the same. If you weight it, it's, I think, if I remember correctly, 10 milligrams of protein per kernel. That number doesn't vary much. What's varying is the amount of starch in there. And so if the amount of starch goes down with the amount of protein held constant, then your protein as a percentage of weight, your protein percentage is going to go up. And we're looking at maybe 14% protein, maybe even higher from some areas, where normally for good malting grade barley, you're looking at 10 to 11.5% protein. So significantly higher, and a lot of problems develop from that high protein. You can see here on the left, it's 40 degrees centigrade there, and that's about 104. And they actually did have some extended periods of 40-degree temperatures up in Saskatchewan. So really very hot. And this guy, I think that says blue as in Labatt blue there, but he's drinking water. So I think beer, a cold beer on a really hot day is always welcome. Finally, here you have drought plus heat, right? And that's the really bad combination. It stresses the plants. And basically they start shutting down in order to survive. So they stop growing in order to survive. That's a survival mechanism. But in the end, that means we're going to have less of that starch available in the kernels. If we look here at the locations, again, this is one of the variables. And the numbers here on the left show growing areas, or the map on the left are the growing areas of the United States. The numbers represent the percentage of barley grown in these states. So you can see here that North Dakota, Montana, Idaho are a large portion of the barley produced in the United States. This is the area that's been hardest hit, and this upper Midwest and Western US. If you look here on the East Coast, where it's just 1%, 2%, and 1%, so 4% of the barley crop grown in the United States comes from this Delaware, Virginia, Pennsylvania, Maryland area, and a little bit into North Carolina. This area, in 2021, actually had a fantastic year. So there are reports of yield increases of 50% over normal, whereas in the Western US, we're looking at yields 30 and 40% below normal. And some are comparing this to the lowest yield in bushels per acre since 1900. So I think the severity and the significance of what we're dealing with this year is unlike anything that any of us brewing right now have seen. There have been years that are close to this. 1988 comes up quite often. And so that's probably for many of us listening at the very beginning of our careers. But so this is I would say a once in a career event that we're going to deal with this year. But don't worry, we'll get through it. Here you see a map of Canada, the main growing regions, Saskatchewan, Alberta, and Manitoba. And this is probably about, I think, 91% of the total Canadian output of barley and malting barley. And these regions, Saskatchewan and Alberta, are just north of the border here, North Dakota, Montana, and Idaho. So that hot, dry weather that affected the northern US also affected these provinces in Canada. So again, looking at the effect of location, and if you're interested down here, Grains Canada does a great job of providing a lot of data and information about malting barley. And this is just a table that I came across from 2016, really to illustrate the effect of location and one of those variables that affects quality. So you have Alberta, Saskatchewan, and Manitoba, 3 different provinces growing barley. It's crop year 2016, so the same year. And if we look here specifically at beta-glucan, the average for barley grown in Alberta was 105. But if you look at the neighboring provinces, Saskatchewan and Manitoba, that beta-glucan was much lower at 69 and 68 ppm. So again, same variety here, CDC Copeland, grown in 3 different provinces, gives you not 3 different results, but certainly for Alberta, quite a significantly different result for beta-glucan. And so that's something to keep in mind. Best information you're going to get is talking to your maltster. That's going to be the person who has the latest and best information to help you manage your brewing process. And they all say that they're fine, but the other maltster is really bad. So I think we're in for quite an experience. It will certainly be one that we remember, and I think we'll learn and get through it. It's not the end of the world. And if you all remember reading from your Joys of Homebrewing book from Charlie Papazian, he said at the end, don't worry, have a homebrew. So everything will be okay. Growing conditions here. On the left, this is from an MBAA Technical Quarterly article written quite a few years ago. These are actually irrigated areas of the Western US. So all these black areas are irrigated for growing barley. If you look here in Canada, most of the barley growing in Canada is dry land. So they have capability of irrigation. I guess it's used for other crops other than barley, but most barley grown in Canada is dry land. Again, that has a difference in how the barley is going to react to the different stress of heat and drought. Don't forget, we normally use grow for malting, 2 different types, varieties of barley, or 2 types. So you have your 2-row and 6-row. In North America, I think everybody is aware that more and more, almost exclusively, we're looking at 2-row barley as opposed to 6-row barley, but 6-row is still out there and grown. Then you have also, this is interesting, that's from the American Malting Barley Association, also a very good and informative website. You have, they put out a list of approved varieties for malting, so approved 2-row varieties and 6-row varieties. Now these are approved for farmers looking to grow malting grade barley. It's not a brewer's approval, it's for the growers. And you can see there are a lot of different varieties of 2-row barley here. All of those will react differently to the stress. You have also spring and winter varieties. And again, those react to stress differently. So a lot of factors in here. It's you have to dig into the details and snoop around a bit to find out what it really means for you. The other part is drought occurrence, or another factor. When did the drought take place? And so here on the left, we have different stages of development. Along the bottom here, and I'll get into this a little bit more in the next slide, is a Zadok's scale. And this assigns a number to the different stages of growth. And these scales help growers and seed providers to talk about different stages, and that's helpful for when to apply fertilizer or fungicide and pesticide. And so you can see there's a lot of growing that needs to be done until we get to the stage where we're actually we have flowered, the plant's flowered, been fertilized, and it's developing kernels. And so if drought happens earlier in the growth of the plant, it's still not helpful, but plants can overcome that somewhat. You can still get through and have a quote unquote average yield. If the drought is happening at the very end here, that's what's really problematic, because the plant wants to survive. So number one is survival for the plant. Number two is growth. And number three is reproduction. For us, we would add, as brewers, number four, I need extract. I want a lot of starch. And so from the plant's standpoint, a sufficient amount of starch is good enough, but a good enough for brewing usually means there's not enough starch. So you're going to have low extract. And if you look here on the right, two things we're always focused on for barley is protein versus starch. I think I can move the gallery here. There we go. So protein, and if you're really looking at protein, that's nitrogen, is I would say much more vital for a plant, because nitrogen is needed for photosynthesis and chlorophyll. So that's just vital for plant growth at any stage of the process. Starch is really building up that storage carbohydrate, that nutrient that the kernels need in order to start germination in the next season. So the plant is going to build up protein and store it first before it reaches the ideal or maximum level of starch. And so when you have that drought happening here at the very late stage, the heading and ripening stage, it's going to affect the buildup of starch much more than it affects the buildup of protein. And so that's why we're talking about high protein, low starch. It's not that it's putting down any more protein, but it finished storing protein first before it finished storing any starch. And that's the situation we've run into this year. And this is a really interesting slide to look at. Protein, again, looking at here, building up protein compared to building up starch. If you look at the level of protein in a barley kernel, it's going to be the same, relatively the same, no matter the climate, the stress, so drought or heat. But the amount of starch that's deposited and built up in those kernels changes. Here, we would like to see an average of 11.5% protein and, or I'm sorry, yes, and your starch here. But in a dry finish year, so a drought and heat, you have the same amount of protein, but much less starch has been deposited in those kernels. And that's why the amount of starch is much less. And that's why you're looking at 15% protein. And this is a situation that we have this year. The other extreme would be a lot of rain, a wet finish, and that's low protein. And that could be a problem too. You might not have enough free amino nitrogen for your yeast. But we're in this situation here this year on the left. The protein level is the same. We just didn't have a chance. The plants did not have a chance to deposit starch in those kernels. And you are looking at 14.5, 14.8, even 15% protein in some barley this year. So definitely will be an issue. And remember, it's if we talk about yeast is not looking to make alcohol for us. We're very fortunate that we can exploit the yeast and that it wants to grow and reproduce. And a byproduct of that growth and reproduction is alcohol. Same thing here with a plant. The plant wants to grow and reproduce. And as brewers, we're taking advantage of that drive because we can capture, we can gather and collect those seeds, and we can use that starch and protein to make beer. So for a plant, this year was not ideal, but they made it through. They've produced seeds that can germinate next year and produce another plant. For us as brewers, it's a little bit more problematic. We would like to see more starch. So here, if you come back, these are two plant scales, two scales used to describe the growth phase of plants, Feeks and Zadoks, and they're different scales, but basically it is used to describe from seedling through to maturity. And we're all the way over here at the end. This is the most important time for us as brewers. We want the seeds to be plump and full of starch and not too much protein. But to get to this point, the plant has to go through so many different stages. And so that drought and that heat in any of these stages has an effect. But when it comes at the end here, that really damages, that limits the amount of starch that we're going to get here in the kernels. One more to look at it, and then I'll move on because it probably we probably had enough. This is just one more scale that illustrates down here on the bottom. So there's no scale here, but there's relative timeline of important steps in growing. And you can see this one here, kernel weight. That's one of the last major things to take place in the plant. You'll see grain yield down here. This is bushels per acre. So that's affected during the whole entire growing stages or growing cycle of the plant. But that kernel weight, that's so important for brewers, is really determined here at the very end. And so I like to think of this as the rooftop bar, right? That's the big attraction. Everybody wants to go to the rooftop bar, and you want it to be on the top of your building. But in order to get to the top floor of the building, you have to start at the beginning. You need to plan it, get your permits, find a contractor, start digging. You have to put up the first floor and the second floor, and let's say you get to the 10th floor, and finally you can put up the rooftop bar. So if none of these stages are here, and this is what a plant is investing all its energy into finally get to this stage, if none of these stages are good, this doesn't happen. So we're at the very tail end of the process here. The other issue we've had this year, and not related to heat or drought, and as somebody said, this is like rubbing salt in the wound. We've had pre-harvest sprouting. So we've gotten to that final stage. We have a limited number of kernels. So on the head of each stalk or plant of barley, you don't have the normal number of kernels that you do. They're reduced. And so that's your yield. That's why your bushels per acre are down. And they also have less starch in them. So our yields in the brew house will also be reduced. But now, this rare occurrence, we have rain at harvest time. This is a trial here on the right, this photograph. And it rains at harvest, and with the moisture and heat, these kernels start to germinate right on the stalk. And this is really a big problem. If you can see in the picture here too, that looks rather dark, and I would say there's probably a lot of mold and fungus growing on there as well. And this is allowed to go to an extreme. If you have pre-harvest sprouting, that barley needs to get to the malt house immediately. A kernel will germinate only once. So once it started germinating, you can't stop that and then start this process again in the brew house. The problem here is that there's a limit to the amount of harvesting equipment, transportation, and also malt house capacity to take all that pre-harvest grain, the chitted or sprouting grain, and get that finished as malt. And so these will die. And there's always a small portion of pre-harvest grain in the malt, but this year the percentage is much, much higher. And so as these die, these are non-viable grains. They can be mashed. Again, there's still extract available, but they're not going to be providing the enzymes that you're looking for in malt. And have no worry, we'll get that, we'll cover that in a few minutes. Why this happens now is because barley has been bred to eliminate dormancy. And so over the years, we're talking thousands and thousands of years, rain at harvest time or rain at maturity, it does happen. And the plant protects itself by going through a phase called dormancy. And what that does is it allows these grains to get wet when it's still warm, but they won't germinate. They're dormant. And that lasts about 3 or 4 months. Well, you can think that if a maltster could reduce dormancy, they could start malting this grain much more quickly. They wouldn't have to buy it and store it for 3 or 4 months before starting to malt the grain. So this means that you can buy the barley and start producing malt right away. You don't need, you can harvest and process the entire year's worth of barley over 12 months rather than waiting 3 or 4 months. And that means you have to process the entire harvest over 8 or 9 months, right? So it spreads out your production cycle to 12 months, and it allows you to utilize your equipment better. The downside, of course, is when we get this rain and pre-harvest sprouting, you're really stuck. It's a real problem to have. Again, from Grains Canada, and again, looking at CDC Copeland, this is a table showing some important parameters for barley. So this is what the farmer is looking at, and this is what the maltster is looking at. And they'll look at things like test weight, kilograms per hectoliter. So that would be approximately our bushel weight. You know, how much starch is in there? How much does a bushel weigh? 1,000 kernel weight, you'll see that on your certificate of analysis. Your plump versus thin, right? So you want plump grains. That's usually a sign of a lot of starch. Thins means low starch, high protein, a lot of husk. And then, of course, you're looking at a protein level. Plump here is going to be over 6/64 if you're looking here in the US, or greater than 2.5 millimeters. And thin kernels, they'll have a diameter greater than 5/64 or 2 millimeters. And if you look here also, you'll hear normally 10 to 11.5% protein. Grown in North America, we're slightly higher. But that's a good rule of thumb. 10 to 11.5% protein is good malting grade barley. We're far above that this year. So finally then, what can we do? And I listed this in order. There's 4 slides here of definitely you're going to have problems with this, to most likely and could be. So definitely you're going to have problems with high beta glucan. And 2 reasons. We mentioned the pre-harvest sprouting. Pre-harvest sprouting almost always is followed by high beta glucan in the barley. The barley has not produced enough enzymes. It hasn't been handled optimally because it's growing out in the field before anybody has actually harvested it. So that beta glucan that is part of the endosperm cell wall is not fully broken down. The other part there is high protein. When you have high protein, we call that a steely malt. Higher starch gives a different texture to the kernel, and it's more mealy or floury. Well, high protein or steely malt does not allow water to pass through as easily as it does with high starch content malt, those floury malts. And when water can't pass through, it can't carry enzymes through to the endosperm to break down the cell wall to get to the starch. So the problem is going to be that you have higher wort viscosity, and that's going to lead to longer lauter times, stuck mash. You can also have difficulties with your beer filtration and centrifuge. So beta glucan can come out of solution on a centrifuge and form a snow globe effect in your packaged beer. There's also a potential for lower extract. The endosperm cell wall is made up of protein and beta glucans, and that has to be broken down before you can get to the starch. So you have limited hydrolysis or limited breakdown of that cell wall, meaning there's more beta glucan in the malt, and it's going to be extracted when you make your wort. So when you do your mashing. You might also, so beta glucan is listed on your COA when you get malt. It will also give you a lower friability. So low friability is also an indication of high beta glucans and a lower level of modification. So when you have a low level of modification, low percentage of friability, that means you also have a tendency for higher beta glucan. And so what you need here is beta glucanase added at the mash, and these have been used for many, many years and quite effectively. So we'll absolutely reduce your wort viscosity and reduce lauter time. You might even see some additional extract when you use a beta glucanase, because you're breaking down that endosperm cell wall, and that means the starch in there, and that's providing the extract, is more readily available to your alpha amylase. The products that we have from IFF and available through Gusmer are Laminex MaxFlow 4G, that is strictly a beta glucanase, and then alphalase AP4 is a blend of beta glucanase, alpha amylase, and a protease. And you'll see why that alphalase AP4 is listed in a minute. Definitely high protein, second problem everyone's going to run into. And the cause of this is drought and heat stress, because the plant, the barley, is not storing starch. It's storing the protein, but not starch. And so that's what we're calling high protein. Again, because that endosperm cell wall is a mix of protein and beta glucan, if you still have high levels of protein, and it's limiting the passage of water and enzymes through the kernel during germination, that means you're going to have higher beta glucans remaining in the malt. You could also have a problem with small starch granules, and that's starch can also cause viscosity problems. Normally in germination and making malt, the small starch granules are consumed. That's supplying the energy to the kernel during germination. And that leaves behind the large starch granules for us in brewing in the brew house. But when you have that higher protein level, you still might have some additional starch granules remaining, especially in those undermodified areas of the malt. And so the malt can be generally undermodified, or if you look at a kernel, you might have parts of that kernel are undermodified or steely. So it varies. Undermodified malt, again, will have higher beta glucans, so leading to higher extract. Higher viscosity, and you also have potentially lower extract. Now, I guess if you look at this and say I have high protein, that means I'm also going to have higher levels of enzyme. That may or may not be true. That depends upon how the maltster is going to kiln the malt before they send it to you, so at the end of germination. But if you do get higher levels of enzyme, and so that's a hot malt, very fast conversion, very high levels of fermentability, you may want to look at and consider changing your mash program with either a higher temperature or a shorter time. If you have a higher temperature, then, and we'll talk about this in the next slide, you might denature your beta amylase, and that's your fermentation, your fermentability enzyme. That's the one producing maltose. But certainly higher protein, so less beer stability, so greater chance for haze formation. You're going to have more trub in the whirlpool. You could have higher wort or beer losses. And in addition to any enzymes that you add to the kettle, you might also want to think of other methods that are used to prevent haze. So that's carrageenan in your kettle, use of isinglass at the end of fermentation, also silica gel and PVPP in filtration or in the cellar. So here for high protein, you'd want to use a protease. That's going to help break down the endosperm cell walls. That's going to allow for greater access to the starch for alpha amylase, and it also is going to provide better access for beta glucanates. So a product that's strictly a protease is alphalase NP, and again, alphalase AP4 is a blend and also includes a protease. So protein is really, can be good or bad, a lot of changes. You can have more FAN in there, leading to more higher alcohols produced in fermentation, possibly more staling. So there's a lot. It's very complex when you're looking at high protein. Most likely here, of course, you'll have less extracts. There's lower levels of starch in this barley, and you might also have more of the small starch granules in the undermodified malt or in the undermodified portions of your malt. And if you think about it, a barley kernel is quite small, and you look at that and say, well, maybe the tip here isn't so well modified, and you multiply that by how many thousands of pounds or kilos is in your grist, then that adds up to a significant portion of undermodified malt in your grist. So really the reason why you would want to add an additional alpha amylase, there could be variability in the enzyme in your malt. You have alpha amylase in there, but it could be variable. So adding an enzyme will help with consistency. You might want to think about using pre-gelatinized flakes to make up for the lower extract from your malt. Because if you're adding more malt, you're wondering, do you really have capacity in your mash tun? If you're adding more malt as well, you're increasing bed depth, and so that adds to lautering problems. We found that pre-gelatinized flakes need the use of an alpha amylase, so you need to add some alpha amylase. They're sold as being pre-gelatinized, but that might not always be the case. And not to say that the millers or producers are doing something wrong. Their process is just different, and they may not be looking at gelatinization the same way that we as brewers would look at that. And most of the time, you might have some small starch granules in. And when you have small starch granules, the gelatinization temperature is much higher. So it's higher than that 149 or that 65 degrees C that we normally would use when we're brewing. It's normally not a problem. You're probably asking, why do I suddenly need a higher gelatinization temperature for malt? It's because you have those small starch granules that normally are not there in the malt. They have been consumed in germination. Starch as well. So if you have a variable amount of alpha amylase in the malt, you have that risk of starch in your wort and beer. That will definitely contribute to lautering problems. Similar to high beta glucan, you can also get a starch haze in your finished beer. If you have a mash mixer, that gives you some more flexibility to adjust temperatures. But if you have a single infusion mash lauter tun, it's practical only to have one set temperature when you mash in your strike temperature. So adding an alpha amylase here in this situation would help. It will give you more extract. We have seen that in trials, when we add alpha amylase, we always get more extract out of the malt when there's alpha amylase addition compared to using the alpha amylase alone that comes with the malt. So in a year that you have a limited amount of starch or less starch than normal, it might pay to add that alpha amylase and get the most out of the starch that you're paying for. So get the most extract possible out of your malt. Also with exogenous alpha amylase or commercial alpha amylase that you purchase, the temperature will not be a problem. These are still active up to 205, 212 degrees Fahrenheit. So up to 100 C or boiling. And so they will not be inactivated. You don't have that risk of being too hot with enzymes that you're adding. And here we would recommend the MLX 6T as an alpha amylase, and again, alphalase AP4 as a blended product. Finally here, maybe it could happen, and it's strange talking about less starch, and you would still need to add alpha amylase or a glucoamylase to increase fermentability. So again, if you have those small starch granules and you have higher temperature in the mash, you're going to denature the beta amylase. Beta amylase is very sensitive to temperature. And so when the temperature, you may run into a situation where the temperature is high enough you need a high temperature to gelatinize those small starch granules. That temperature could be higher than beta amylase can handle. And so you're denaturing and destroying the beta amylase. So you'll get your extract, but the fermentability will be low. In this case, it would help to add a glucoamylase. Now you're not looking at high fermentability in the beer. You want to increase it and get back to your target. So a glucoamylase addition here would help produce, give you higher fermentability. And what we would recommend is diazyme TGA. And again, if you're looking for a blend, alpha lase AP4. And so there's a few ways to look at this. If you feel you know exactly what the problem is and you want to buy an enzyme just for that one problem, you can buy the individual enzymes, or if you want a blend to take care of all the problems with one simple addition, then a blended product like alpha lase AP4 would help. If you're looking for some additional information on this, there are two really good webinars out there. If you're a member of MBAA or the Brewers Association, you can go back and look at these. So from the MBAA on their podcasts, the Challenging 2021 Barley Outlook, and then Brewers Association from Barley to Beer. And both of these deal and talk about quite in depth, quite extensively, what's happening with the 2021 barley crop and what you can do to manage that once that malt starts coming into your brew house. And that will probably happen as early as December. So next month, and certainly well on into January, February, and March. So, the barley yields at harvest are down. That means if you haven't already, make sure you're talking to your maltster to secure supplies. So lowest yields in 120 years for the US. There are many factors too that affect barley quality and malt quality. And so again, talk to your maltster. This is the person who's going to have the best information for the barley that they're buying and selling to you as malt. We went through a lot of variables, and not every variable is going to affect every variety of barley grown or every growing area. So your maltster is really that key person to talk to get a better idea of what to expect and what you can do. And then finally, talk to your customer technical sales rep. This will be your first point of contact, and they can help you as well with enzymes or other process aids as we start using this problematic and troublesome barley and malt. I think it will be difficult, but if you understand the germination process and the enzymes, the key enzymes, that's what's available to add commercially. So basically, you'll be able to finish up or top up enzymes in the brew house. You can finish up the modification in the brew house by adding those enzymes that are necessary for producing good malt. You're doing it in the brew house. And it's already, many of you are already doing this. I suspect a lot more of you will do that too. And at the end of the day, I think we'll certainly learn a lot. This is not an event that happens too frequently, and it will be a good experience. And with a little bit of patience and planning, I think we'll be able to do all right and get through this and keep producing beer. So anyway, that's it. Thank you very much. And I think now we'll go to questions.
Great, thank you so much, Andrew. All right. I actually have a question. When it comes to talking to your maltster about, what potential issues you could be facing with the malt that you're getting, are there any types of reports or anything that you should be looking for specifically from your maltster?
Well, I would ask for the certificate of analysis, and ideally, if you could get a certificate of analysis for the lot that they're shipping to you. That's where it's really important this year to have the best and latest information.
All right, that question from Jay Long just came through. What will be the typical dosing rate for enzymes?
That all depends which enzyme and how significant the problem, but you're looking at normally 100 milliliters per metric ton, so 100 milliliters in 2,200 pounds of grist. The rule of thumb, but it could vary.
Yes, yeah. As Andrew said, it'll depend on the type of enzyme. And as he mentioned, a good starting point is to talk to your technical sales rep just to kind of get an understanding of what enzyme you're looking at, and then we can kind of go look at the dose rate from there.
Right, and what you're trying to do as well. Yeah.
Mm-hmm. Next question here. Can you talk specifically about which enzymes might be higher in a high protein situation, depending on kilning?
Well, I mean, so if you have higher protein, there's the potential there to produce more enzymes during germination. But that also depends upon maintaining that balance. So if you have a high beta glucan, you need more time to break down the beta glucan, and the malt, the germinating kernel, is producing beta glucanase, and you need time for that to work. But at the same time, you're producing beta glucanase that you want and you need. You're also producing alpha amylase, beta amylase, and a whole host. There's probably 40, 50, even 60 enzymes that are produced in the germinating barley at the malt house. A lot of these enzymes are sensitive to heat, so that kilning cycle has a large impact on which of those enzymes will typically survive. So long kilning at high temperatures will inactivate a lot of enzymes. So that at the end, really, normally we're looking at alpha amylase and beta amylase. So your diastatic units, diastatic power, or alpha amylase that you see on your typical certificate of analysis. And so that's where protein is, there's a lot of details and levels and layers when you're talking about protein in barley and what that means for the finished malt that you're getting. And one of those, I mentioned the two webinars. On the MBAA webinar, one of the maltsters said we'd probably want to under-modify our malt a bit. So that means you're going to be looking at high beta glucan, lower protein, lower S/Ts. And then on the Brewers Association podcast, one of the maltsters said, we're probably going to want to over-modify, right? So two maltsters talking about the same situation, giving you two different opinions on the best way to handle it. And that depends upon the barley that they're buying, their equipment and capabilities. So a lot of factors there.
Great, thank you, Andrew. There is a follow-up to that question.
Okay.
Also, do we know if these challenging weather conditions might have an impact on SMM or DMS in barley?
Yes, and I spoke about this with one of my colleagues. High protein usually means a higher SMM or higher DMS. Now, the only reason, and somebody, I think there's some people here from the maltsters online, they might jump in. My guess is that this is going to happen if you are under modifying the malt, because DMS comes from SMM, and that's really developed during germination. So a lot of that DMS is driven off during kilning and then again during the kettle boil. So if you have high protein and you're not germinating as much, so lower levels of modification, then that leads me to believe this is the source of higher DMS.
Thank you, Andrew. And we do have another question. What would be the dosing rate for the alphalase AP4? Are we going to see limited availability due to demand? How much more will that increase the cost of our beers?
Dosing rate of AP4, off the top of my head, again, it's probably 250 milliliters per ton of grist. Limited availability due to demand. That's an interesting question. I think like everyone else and every company right now in the economy, we're ordering what we can when we can, because there are a lot of supply constraints. So it would be a good idea to plan ahead. How much will that increase the cost of your beers? As a supplier, we are not allowed to know the price that our distributor would charge you. So I can't say, but not significant. I think your labor and your packaging, cans are much higher proportion of the finished package than enzymes are. Enzymes are generally very inexpensive if you look at the cost, the total cost of production.
Yes, and then I'll just add on to that. Generally with enzymes, you're looking to use the enzymes to kind of help you with your efficiency and your process as well. So you could eventually end up saving some money on the processing side, depending on the type of quality of malt that you have. You could get better yields from it rather than, you know, leaving money on the table, as Andrew likes to say all the time. So
I do, especially when we go out.
Okay. Well, thank you everybody for your time again. And thank you, Andrew, for taking the time to go over this presentation with us. And if you do have any questions later on that come up, feel free to reach out to your local customer rep, and we'll go ahead and put you in contact with the technical service rep or Andrew if it's something that he can help with.
Absolutely, anytime. And thank you everybody for joining, and thank you to Gusmer Enterprises for allowing me to present today.
Great, thanks, Andrew.
All right, bye now.
Right, bye.